Hello there. Today we are going to dance around SQL, and the dance floors are going to be user-defined functions. By the end of this video, you should be able to write a query like this one here. This query retrieves students' eligibility for scholarships using user-defined functions, stores it in a materialized view, then displays the materialized view. Let me run this query real quick just to ensure that it's not buggy, and voila, this is what we expect to see by the end of this video, and you should be able to display this if you're following along. I am Dalmas and welcome back to DaliCodes, or welcome to DaliCodes if you're new here. This is the best YouTube channel for data engineering and data science. A user-defined function, also known as UDF, is a group of arbitrary SQL statements designated to perform some task. Once the function is compiled, the code can be reused over and over again. Here is how to create a user-defined function. A user-defined function is made up of two sections, the header and the body. The syntax of a UDF reads like: create a function of function name with arguments that return an object of a data type. The function is defined as anything between the dollar signs, and variables are declared in the declare section. The query is written between the begin and the end section. The procedural language used is in the language definition, and the languages that you can use for user-defined functions are SQL, C, PGSQL, and Python. In my PC, I have a database having a table containing student information. In this database, we are going to create several user-defined functions, and the link to the data that I used to create this database can be found in the description of this video. Please check it out, download the data, and move it into a Postgres database if you want to follow along. Let's start by creating a UDF that returns an integer. This will be a function that returns the number of students in the students info table. So we start by create or replace if that user-defined function exists. Function. So create or replace a function, and I'm going to call this function get number of students. Get number of students. Then we are not going to pass any argument. It will just be a function that takes no parameters. We expect this function to return an integer, and the language that this function will be using will be PGSQL. So language, so we are going to define this function as, and whatever is in between these dollar signs. Where is my dollar sign? Will be the definition of the function. So let's declare the variables that we're going to use here. So I'm going to declare a variable called student count, and it is an integer, and it is the variable that we're going to return. Then we begin and end here, and what we want is to count all records in the students info table. So select count all. The value should go into student count. From the table is in a public schema, student info. We want this function to return student count. So this will be the function that returns the count of students in the student info table. I could count the ID, but I assume that in the student info table each record is a student, but you could also just count distinct ID. So let me run this, and you can see that the create function is successful. So how do you invoke this function? I'm going to write it here. So we're going to invoke it through select, and we're going to select this. This should return to us the count of students in the student info table. So let's try this. We can see we have 32,593 students, and we can confirm this by running this query after. So let's run this. Oh, and this should be us. Still the same value. So this is how you create a function that returns the count of records in a table. And when we refresh this function here on this UI, we can see that now we have get number of students function created. I also have this get scholarship, which I created when I was showing you the query that we are going to write at the end of this video. I can delete it. Oh, it's dependent on something. I'm just going to delete cascade. Right, so this is our first function. Now let's add arguments to these functions for a filter of gender. The purpose is to filter data depending on the gender of the student. So I'm going to clean this up a little for readability. I think that is okay. Put this on here. Right, so what I want now is to pass here a variable. I'll call this variable gen, and the variable that I expect is a variable character. Then I'm going to use that variable here. Just going to clean this a bit, where we need to know. So I'm going to know the column for gender. So I'm just going to write select star. From that, we go on to return everything. Let me run this. So the column for gender is called gender. So where gender equals to the variable that was passed, gen. Then let's invoke that function. So we have seen here the gender can be M or F. So we're going to say M. I'm going to run this function twice, then F, and it should not be in double quotes, it should be in a single quote. Double quote means variable, which could not be, there's a possibility of it not being defined. So let's run this. Oh, we need to rerun the creation of this function. Then I'm going to run this. Voila, now we can see this is number of students who are male, and then this is number of students who are female. We could just say here, this one returns as males, and then as females. So we run this, and you can see males are this, females are this. So this is how you create a function or a user-defined function that has parameters or variables that you pass as arguments. What if we want a user-defined function that returns a table? So far, I know how to create a user-defined function that returns a table, but the table is of one column, and that column contains table values as tuples in a column. Let's create one, and you see what it means. I don't know how useful this will be for an analyst, but it's good to know. Or if you know how useful this will be, you can leave a comment just for me to learn and everyone else who doesn't know how to do this, how to use this, I mean. So create or replace a function, not a function, create or replace function, and this function should return a table. I'm going to call this function get student band. We expect it to return, so the returns should be a table, and the table should have these columns: highest education, and this is a variable character. We should expect IMD band. These are columns that are in that table. This is also a variable character. We should also expect age band, which is also a variable character. And the definition of this query or this function should be here. So we're going to begin, and we are going to end, and what we're going to return should be the query. So we're going to return query, and the query should be whatever we are selecting now. Select highest education. I'm just going to copy them from here. Highest education, IMDb band, IMD band. I even don't know what IMD band is, and age band. From, let me just clean this for readability. I'm usually careful about readability of query because someone else may be looking into your query. You don't want it to be trashy. Public dot student info. As SI, I want to be explicit of where the columns are coming from. So si.highestEducation, si.imdemand, si.hband. And I want unique values. I could use distinct, but let me use group by. So group by column 1, column 2, and column 3. And we have the end here. And we can also define the language at the end, and the language is the same as the previous function that we have created, which is LPGSQL. So we have this as a second function. I'm going to run it. Syntax error at the end. Let's terminate this here, run it again, and the function is created. When we refresh, we can see that we have get number of students here. Is it get number of students? It's get student band. I mean, get student band is here. So let's invoke that function, and we see what I was telling you. So select this, run this, and we can see the result is each value is a tuple of what we expect here. So this is how you return a table, yeah, but it's like one column and these values are in one. It's like a list. I don't know how useful this will be, but I think it's useful somewhere. That's why the feature exists. Now for the main event, let's create a materialized view that takes advantage of UDFs. The first thing we need to do is to create that UDF, and the UDF we are going to create is a UDF that returns a student's eligibility for scholarship. So let's begin. We are going to create still or replace, if it exists, function, and we're going to call this function get scholarship. The variables that this function is going to take will be highest education, what's happening, which is a variable character. It's going to take age band, disability. These are all columns that disability. These are all columns that are in that table. We're going to look at student credit or studied credit. Which is integer. We shall expect it to be an integer. Then final result, which is a variable character. So final result is like pass or fail. So we're going to use these variables that are gotten from still student info for each student and determine whether the student is eligible for a scholarship or not. So for this function, we expect it to return a boolean, true or false. And the language we are going to use is the same as for all the previous functions we have created in this video, PGSQL. So let's define the function. So I'm going to just do this. We begin by declaring what we want to return. So I will declare, I'll call these variables called shape, eligibility, and it's a boolean. Then our block, so begin and end block. Then we're going to have our query inside here. So select, I want to use the variables that were passed here to determine scholarship eligibility. So we are going to use case statement and some criteria that I defined before this. So let's look at this. So select case when we start with the final result. So if final result is a distinction, so we want students who have distinctions to be eligible. So if it is a distinction and your highest education is A level or equivalent, so let me just put it here. So highest education is A level or equivalent, and your age is 0 to 35, and your credits will be above 150, so studied credits. And studied credits here should be integer, yeah. So it's above 150, then you're eligible. We return 1 or true. Let me return 1. For students with disability, so when I'm going to copy this, so when your final result is pass, for students with disability who are from A level and their age is 0 to 35, and their credits is above 150, and disability is yes, then they're eligible. So you can see we have given a leeway for students with disability on the final result. Else, if you don't fit any of those two criteria, then you are not eligible because there are so many people. So else 0, and then this case statement will return. So here is going to create a column, and whatever is going to be there should go into this variable, and that's the end of our query. Then we're going to return this variable. And then we have the end of our definition block, and voila. So that's going to be our function. So our function to get scholarship gets all these values, 1 2 3 4 5, these values here, and when it gets these values, it's going to return a 1 or a 0, which will be converted obviously to a boolean, and it returns a 1 if the student is eligible for scholarship and 0 if they're not. We are going to use this function together with the definition of a materialized view to be able to have a materialized view for students who are eligible for scholarship. So the next thing we're going to do, let's first run this just to be sure that we don't have bugs. Yeah, so we have a bug, syntax error at the point. This is going to take time debugging. Let me run it again. Yeah, so it's pointing here for a syntax error, but that means that there could be something wrong as from the beginning. So declare eligibility boolean case when this looks fine. We have and here. Oh, we're missing some end to our case. So case when this, else that, else 0. So we should end our case statement here. So let's run this. Voila. So we have now a function that will get scholarship. We can invoke this just to be sure. So we can do select this, highest education, I can say A level or equivalent, age band 0 to 35, disability, no, studied credits, can say 180 or 160, final result, distinction, then run this. Oh, we need a comma here. Run this. True, we are eligible for scholarship. We can say pass. False, we are not eligible. So the function is working. Now let's define a materialized view that we shall take advantage of this function with. So create materialized view. If you're new to materialized view, I have a video in the description, this video here, that shows how to create materialized view and the advantages of using materialized view over the normal views. So create materialized view, and I'm going to call this student scholarship eligibility. So student scholarship eligibility as, then the query select. What do I want to see? I'm going to select all from public.studentinfo where This is where now I'm going to use the function to filter who is eligible and who is not. So where get scholarship is going to return true or false, and then this is going to be highest education, age band, disability, these are columns still of the table, studied credits, and this we're going to cast it into integer, then final results. I'm going to define the columns that I want here. Just going to copy them from here. So these are the columns that I want for materialized view, not all of them. Then let's run this. Voila, we are successful. So the materialized view was created. We can now check this view and see the data that is in it. So select all from that materialized view. Use this thing here, run. Voila, so now we have how many people? 33 people who are eligible for scholarship. Some of them have pass, some of them have distinction, but I think these people with pass are the ones who with disability. I'm going to check. Yes, they have disability but with pass, so it helps them, but they still have the criteria. Right, so this is how you work with user-defined functions. There are different ways of calling the user-defined functions. You've seen one which is just passing the values directly. We have other ways, like you can define the highest education equals the highest education and so forth. They're just different notational and positional ways of defining user-defined functions, and it's the same for all languages, even if you're writing JavaScript or Python. And also, just so you know, the advantages of using user-defined functions, they're easy to invoke. See the way I've just been invoking them. They can be used in multiple places. So you saw when we were working with the gender and getting number of students by gender, and we called it twice, so that means that you can invoke it anywhere in many places, not just you, but several other people who are accessing the database can access your functions, and they can use them in where they feel necessary. And then also the functions allow function overloading. And the only disadvantage that I've seen so far with the user-defined function is that they don't handle transactions well, or they cannot handle transactions. For example, if you want to create a UDF that has a commit or a rollback, it's impossible. We can try that. So we can say create or replace a function. I'm going to call it AFFFN as the name of the function, and this function takes in n, which is an integer, and returns void. It returns nothing. Then let's define this function. Keep on forgetting where my dollars are. Then inside here I'll just write begin, and then I'll do commit, then end. and then I am going to define the function. Let me first terminate this. Then the language is postgresql. So when you try to create this function here, you're going to see an error. Let's run this. Pass a value here, 10. Invalid transaction termination. Yeah, so we can't do transactions with user-defined functions. One more thing that I want to show you is, for now we can see the user-defined functions here on the interface if you're using pgadmin, but in case you don't have, your UI doesn't have access to your server, you can log into your server on terminal, and let me show you how to list user-defined functions from terminal. So I'm going to log into the terminal, that is PSQL, and then the host, I'm on localhost, so localhost of port 5, the default port 5432. My user is, I remember, was Dalmas, and the database that we're using now, that we've been playing with, is Open University. So Open University. And let's sign in. So now we're in this DB. So if you want to check all the functions, you do /df, and then I want to check in the schema of public, so public.store. So when you run this, you'll see all your functions. There's so much information that is returned here. I'm going to reduce the size of this so that they all fit in one screen. So we can see here that we have 4 functions that we defined, which is here. So that is the way you can list functions in the terminal. And so far you've made it to the end of this video. Thank you for watching, and hopefully that you've learned something. Please find the reading materials that I used to make the video in the description. Subscribe if you have not, like if you've learned something new, share this video with anyone you think may need it, and I leave you with this quote that I learned from someone on the internet. Until next time, keep learning.